There's a harmonic series in math and there's a harmonic series in music, and they're related. On a string instrument like a violin, the string is attached at both ends and then you make it vibrate in between those ends. You change the pitch of the note by changing the length of the string by putting your finger down. If we look at the picture of a sine wave going between those two ends, here's what it looks like. But there's another sine wave that could also fit between those two ends, which has half the wavelength, and another one that would fit with a third of the wavelength, and another with a quarter, and another with a fifth. Those fractions are the harmonic series in math, and those wavelengths give us the harmonic series in music. If I put my finger down halfway up the string, this is the open string and it's fixed here and here, halfway up is maybe about there. Let's see what note it makes. It makes the note exactly 1 octave above. And if I go to making it 1/3 of the length, that's about here, then it's a fifth above that. And those pitches are the harmonic series in music. On the piano, it's the same thing, except the strings are inside the piano. This string is half the length of that one, and then we have a third, a fourth, a fifth, a sixth, and a seventh, and that is the harmonic series. If I hold down the upper notes without striking them, and I just hit the bottom note, the sympathetic resonance of those harmonics will be set off. I can also hold down the bottom note so just the long string is free to vibrate, and if I play all the chromatic scale notes, that's all the notes on the piano, only the ones in the harmonic series will resonate with that bottom one. I can play harmonics on the violin by lightly touching my finger on the string at the correct point instead of actually putting my finger down. Here's an open G, and if I just lightly touch my finger on it halfway up, I'll make a harmonic. This sounds different from if I actually put my finger down, which makes the string shorter rather than just isolating the upper harmonic. I can then find the one that's a third of the wavelength, and then a quarter, and then a fifth, a sixth, gets harder as they get shorter, a seventh, it's just about in there. Those sounds are a bit more fluty sounding than a normal violin sound, and composers sometimes use that as a special effect. For example, here's the Méditation by Massenet. There's math inherently in the way that sound is produced, which is really on the borderline with physics. And sometimes we don't control it deliberately, but sometimes composers do use it deliberately for special effects in their music.